3 interstellar visitors. Different paths. 1 hidden pattern. ʻOumuamua, Borisov, and now 3I Atlas. Each slipped in from deep space, traced a route that feels deliberate, then left without a stopover. They moved like survey craft, sniff the air, sample chemistry, transmit findings, and move on. 3 passes, 3 reports, each brushing by Mars, Venus, Jupiter. Earth avoided, as if our profile was logged long ago. 3I Atlas didn't break that trend. It refined it. Stay through the end. We're going to connect these tracks and face a truth few are ready to hear. There are nights when the cosmos hands you something you didn't plan for. July 1st, 2025 was one of them. A Chilean node of the Atlas network flagged a wanderer that didn't fit the local family. The designation followed, 3I Atlas, the third confirmed interstellar object. Trace its path backward and forward and your pulse climbs. The track isn't a meander. It's a needle through a loom. Bound visitors circle. They return. They obey ellipses. This one does none of that. A hyperbola means it came from outside and will head back into the dark. That part tracks with expectation. The route it takes through our system does not. Picture an intruder arriving from Sagittarius at roughly 60 km per second. It slides into the planetary plane and threads past targets with surgical care. Around October 3, 2025 it passes Mars at about 19 cents. On October 29 to 30th it grazes perihelion near 1.36 to 1.40 AU, between Earth and Mars. November 3, 2025 it sweeps by Venus at roughly 65 cents. On March 16, 2026 it crosses the Jovian realm near 35 cents. 3 worlds. 3 specific case studies. Earth is not among them. Think about the set. Mars is the dry relic, a place where rivers once ran before its sky thinned and warmth bled away. Venus is the burned twin, a co-furnace with acid clouds. Jupiter anchors a family of ice-covered ocean worlds, Europa, Ganymede, Callisto, where water hides beneath shells and heat seeps from tidal strain. Dry past. Toxic failure. Hidden oceans that may still breathe. A progression across habitability states, sampled in sequence, while the only proven biosphere in the system is skipped. You could chalk it up to chance. Space is wide and our minds hunt patterns. Then you look closer. The orbit is retrograde. The inclination sits within -5 degrees of the ecliptic, while the direction is -175 degrees, nearly counterflow but nearly coplanar. That alignment maximizes meetings with planetary paths. Most interstellar visitors cut through at odd angles, miss the lanes, and vanish. This one came in flat, where the worlds are. Then comes the chemistry. JWST watched the coma and read a spectrum where Co dominates HO by roughly 8:1, among the highest ratios ever seen for a comet. Co defines Mars and Venus. Mars is -95% Co. Venus is -96.5% Co. A co-rich interstellar visitor tracks past both, then moves on to Jupiter's ocean world precinct. If the target were Earth, you would expect a water-forward profile. You do not see that. You see something else. The safe read labels it a comet from another sun, irregular rock and ice knocked loose eons ago, now venting gas as it warms. That fits much of the data. Yet the geometry keeps tugging at the mind. Flat entry. Corridor threading. A volatile mix that mirrors the atmospheres along its lane. If the path is chosen, not random, the picture shifts. Discovery was almost dull. Atlas caught a moving dot, and archive pulls showed we missed it for weeks. Once the fit landed, the numbers said hyperbolic without ambiguity. ʻOumuamua did this. Borisov did this. Now 3I Atlas does it with an added twist, nearly coplanar, retrograde, and timed to cross 3 prime laboratories while Earth looks on from a distance. Mars near 19 cents while orbiters and rovers blanket it. Perihelion between Earth and Mars. Venus near 65 cents as missions spool up. Jupiter at 35 cents with Juno on station and JUICE and Europa Clipper in the queue. The statistical odds quoted for that sequence sit well below 1%. Not impossible. Uncomfortable. Comets vary. Diversity alone proves little. Yet the triad tells a story. ʻOumuamua dry, no visible coma, odd light curve. Borisov active, classic ice behavior. Atlas co-forward, plane threading, retrograde. 3 fingerprints. If you were building a survey, you would not send the same tool to every environment. You would specialize payloads. Now the hypotheses come into focus. Instrument hitchhiker. The object chooses lanes where we have sensors, orbiters at Mars and Venus, a fleet at Jupiter, ground arrays on Earth, JWST above. Each time we observe, we reveal tactics, timing, and capacity. Our measurements race across networks. If something out there listens, it collects our notes about ourselves. Resource grazer. A co-rich body takes a path past the 2 largest co-reservoirs in the inner system. At Mars you can map the exosphere and seasonal flux. At Venus you can ride the extended tail and pick up escaping particles far from the crushing lower sky. If you wish to stockpile or process split it, store oxygen, synthesize methane, run a heat engine, that corridor makes sense. Reconnaissance. Send one object through the regions we monitor most, then log detection time, retarget speed, interagency coordination, and blind spots. The coma cloaks the core. Jets look natural and provide plausible thrust. Small tweaks vanish into models of outgassing. Trojan horse. A dusty coma is a perfect veil. If the nucleus holds micropayloads, they could drift out hidden in jet plumes, then navigate toward Mars orbit, Venus's cloud deck, or the Jovian system. Dustcoat wafers would read as debris. We track the main body and miss the seeds. None of this is proven. Natural paths and chemistry cover much ground. Cosmic rays can turn CO into CO over deep time. Formation beyond a co-frost line can enrich the mix. But the pileup of almost too neat details keeps the door open. Now widen the frame. Our telescopes are starting to catch exoplanet air with hints of life. In 2025, teams reported a nearby temperate world with oxygen, ozone, and methane in disequilibrium, exactly the kind of chemical imbalance life makes here. Several other targets look promising. Remote spectra can flag living skies, but they do not tell you enough. Ground truth still matters. That is where probes come in. A lane that hits Mars, lost habitability, Venus, runaway greenhouse, and Europa-class oceans, concealed habitability, gathers the edges of the distribution Earth does not capture. Jupiter amplifies all of this. Juno's magnetometer work sharpened the view of Europa's global ocean and Ganymede's minamagnetosphere. Radiation, plasma, induced currents, this is the largest electromagnetic structure in the system. An interstellar passerby at ~0.35 AU will feel it. If you want to learn how magnetospheres feed surface chemistry, seed oxygen, and stress ice shells, this is the lab. It is also a vast, noisy place to hide small things. Meanwhile, our own machines are getting smarter. In 2025, autonomy advanced across fleets, small SATs that pick targets and coordinate, rovers that plan routes and choose samples, deep learning systems that flag odd light curves and spectra. If we are building swarms that think for themselves within decades of modern AI, imagine what a million-year head start yields. A network of quiet agents would not beacon. It would learn, adapt, and blend into natural variants. We are also waking up to a gap. Detection is no longer the bottleneck. Interception is. ESA's Comet Interceptor points the way, wait on station, then sprint to a target. NASA studies fast, small chases. The window is tight. We missed ʻOumuamua up close. We watched Borisov from afar. Atlas is here now, yet no interceptor is on the way. By the next one, that may change. Readiness itself becomes a signal to any watcher. We moved from passive to active. So what does 3i Atlas tell us right now? On the surface, an interstellar comet with a hyperbolic path, retrograde, nearly coplanar, venting at unusual ratios, moving through a corridor that happens to be rich in our instruments. Underneath, a pattern that might reflect design, or the long tail of probability teasing our pattern hunger. If it is engineered, then a larger census may already exist. Not a broadcast, but a ledger that marks worlds as habitable, failed, or promising. Earth's row would read, inhabited, technological, status active. Being noticed is not the same as being addressed. There is no greeting here. No pause. No break burn. Only a pass, a turn, a glide toward Jupiter, and exit. There is another reading that is kinder to caution. No intent, only physics and ice. A body formed cold, processed by radiation, tossed from a distant nursery, now taking a path that by chance skims 3 laboratories we care about. If that is where the chips fall, it still matters. We still learn how alien comets are made. We still test our instruments on the rarest targets. Either way, the next months are key. The Venus leg sits near early November 2025. The Jupiter sweep lands March 16, 2026. Juno is in place. Ground arrays are primed. JWST will listen when geometry allows. Watch for changes that break thermal expectations, activity spikes that do not match solar heating, hints of non-gravitational nudges that exceed jet models, composition shifts tied to waypoints. If nothing odd appears, the file closes as natural, unusual, instructive. If even one durable anomaly survives scrutiny, the conversation shifts. Then the pressure rises to meet a future visitor with an interceptor and bring back answers instead of questions. Here is the uncomfortable gift: either outcome reshapes us. If natural, the galaxy is busy enough to throw many kinds of messengers through our sky, and we must be ready to catch them. If designed, we are already in someone's dataset, and our choices, how we manage our planet, how we handle risk, how we step outward, become part of a longer record. 3i Atlas will fade. The coma will thin. The trail will slip beyond reach. The sky will quiet. But the pattern will stay on our desks. 3 interstellar visitors, 3 different chemistries, 3 different roles. The surveys we run will get sharper. The next alert will come. And when it does, we owe ourselves more than a press release. We owe ourselves proximity, images, samples, numbers you can hold in your hand. Until then, keep your eyes on the corridor, Mars behind, Venus near, Jupiter ahead, and on the faint, steady possibility that the universe has been talking to us in the only language it trusts: motion, matter, and timing. And so, 3i Atlas keeps moving. An ember of another sun, cutting across our neighborhood with the patience of eternity. Every calculation confirms its exit. No return, no capture, no orbit, only departure. But in the departure lies meaning, because every line it draws adds to a geometry that refuses to vanish. The telescopes keep watching. Chile, Hawaii, Canary Islands, orbiting eyes above the atmosphere. Each night they gather photons that left the object minutes ago, mapping its coma, tracing its jets, fitting light curves to models that do not quite match. The models are good, but never perfect. The brightness varies when it shouldn't. The jet shifts direction by fractions of a degree that do not line up with sunlight or spin. Small things, easy to explain away. Yet science lives in the residue of anomalies. Teams argue across continents. Is the codominant surface deep or core deep? Is the jet pattern rotational or directional? Does the object accelerate slightly more than outgassing predicts? Each question spawns a dozen papers, each paper 1,000 data points, and somewhere between them the possibility grows that we are not describing a coincidence but following an intention written in orbital mechanics. By December 2025, the coma begins to thin. Solar heating drops as it pulls away from perihelion. Infrared instruments detect subtle changes in spectrum, less dust, more pure gas, higher CO to CO ratio. That implies depletion of lighter volatiles. Or, if you believe the more daring analysis, controlled venting, a regulated exhaust pattern designed to manage momentum. Control would mean navigation. Navigation would mean purpose. And purpose changes everything. Back on Earth, the debate splits along familiar lines. Half the community holds to natural origin. Hyperbolic comets are bound to vary. The other half whispers about engineered trajectories, about reconnaissance disguised as randomness. Publicly, nobody commits. Privately, some admit they no longer sleep well. Because if this object is natural, the universe is astonishing. If it isn't, the universe is aware. February 2026. 3 months from Jupiter. Juno's instruments are recalibrated for a possible flyby observation. ESA's JUICE team shifts schedules to leave a window open. Europa Clipper's mission control updates its trajectory database with a hypothetical Atlas encounter. The chatter builds. Spectroscopists want composition. Plasma physicists want field data. Everyone wants the one frame that will show detail through the coma, something solid, structured, artificial, or conclusively chaotic. But space has its own silence. Signals lag by nearly an hour. Weather blinds ground telescopes. Half the data comes through smeared by solar interference. When they clean it up, they find a flare of brightness near February 27th, a short, intense burst that fades within hours. It looks like a jet outburst, but the direction is odd, not sunward, not perpendicular, but tangent, as if correcting course. The trajectory changes by a hair's breadth, barely measurable, yet enough to shift the Jupiter encounter timing by several minutes. Natural? Possibly. But coincidence keeps losing ground. March 16, 2026. Jupiter. 3I Atlas crosses the edge of the magnetosphere. Charged particles slam into the coma, stripping electrons, ionizing dust. Juno's magnetometer registers an unexplained pulse, a brief local distortion that doesn't match known plasma dynamics. The waveform resembles a data burst, structured, repeating, compressed within milliseconds. No radio signature accompanies it. No frequency drift. Just a magnetic whisper in the noise. Analysts debate it for weeks. Most label it instrumental artifact. A few quietly file it under unclassified anomaly. And then the object is gone. By May 2026, 3I Atlas fades beyond Jupiter's reach. Ground telescopes can barely see it. Infrared returns only darkness. The official summary reads, Interstellar Comet 3I, Atlas, hyperbolic object, co-rich, non-returning, natural origin probable. End of entry. But off the record, notebooks fill with unease. The geometry lingers. Mars, Venus, Jupiter. Habitability sequence. And the magnetometer pulse that no one wants to name. Months pass. The media cycle moves on. Yet among astronomers, an unspoken consensus forms. Prepare for the next one. Budget proposals multiply. Interceptor designs accelerate. Microprobes, laser sail chasers, swarms of autonomous scouts. No one says 4 alien probes, but everyone thinks it. Because once is chance, twice is coincidence, 3 times is pattern. Summer 2026. JWST detects another object far out near Neptune's orbit. Dim, fast, off-angle. Preliminary analysis suggests an inbound trajectory from Hercules. Velocity, 72 kilometers per second. Inclination, 6 degrees off the ecliptic. Designation pending. Early simulations project a passage through the inner system by 2028. The thread continues. Back in the data archives, researchers re-examine ʻOumuamua and Borisov with new algorithms. Machine learning trained on the Atlas dataset finds subtle alignments, tiny consistencies in angular momentum vectors, compositional echoes, timing resonances relative to planetary positions. Individually meaningless. Collectively, improbable. The program flags the trio as a coherent sequence. No one publishes that word. They substitute unexplained correlation. Meanwhile, theoretical papers bloom. Some model an ancient galactic network, autonomous probes seeded eons ago, each self-replicating from local material, each updating a slow-moving census of life. Others argue for statistical bias. We only detect visitors that happen to cross our instrumented plane, so of course they look purposeful. But even skeptics admit the odds feel thin. In 2027, a new branch of planetary defense forms: Interstellar Object Rapid Response. Mandate: immediate interception within 1 year of detection. Global coordination between NASA, ESA, ISRO, JAXA, CNSA. For once, politics bows to curiosity. Because everyone wants to know what these things are. And beneath the policy briefings and engineering schedules, deeper questions spread. If the galaxy runs a census, what category do we occupy? Technological, developing? Hostile, monitor? Stable, observe? Or just routine biological, no intervention required? Each possibility humbles the imagination. By late 2027, the outbound trajectory of 3I Atlas drifts beyond the Kuiper belt. No one is watching continuously anymore. But every few weeks, a deep space array pings its coordinates, measuring faint reflected light. One return shows a faint secondary glint, too constant for random dust, too narrow for reflection. The brightness ratio suggests something small orbiting a few kilometers off the nucleus. Maybe a fragment, maybe not. Then the signal disappears. The object continues outward. Solar influence fades. Temperature drops to the edge of molecular motion. Instruments fall silent, or seem to. And somewhere beyond Pluto's orbit, a pulse of infrared energy flickers once, low and short, and vanishes into the void. Officially, no one mentions it. Unofficially, it becomes the new campfire story among astronomers. The Atlas Echo, they call it. One burst of warmth in the cold. Years will pass before the next confirmed interstellar visitor appears, but when it does, the world will be ready. Launch systems will wait on alert. Cameras will be pointed. Sensors tuned. We'll have the tools to see it up close, to peel the coma and reveal the nucleus. To settle, finally, whether these are the universe's stray stones or its messengers. Until then, we stand under our own sky, the same sky every civilization before us feared and loved. We build machines that listen. We send signals. We draw maps of dust. We measure what passes through and what passes beyond. Because that's what we do when the universe knocks. We answer with data, with questions, with awe. Somewhere between Mars and Jupiter, there is a line of invisible markers, positions where an alien hand, real or imagined, once traced a path. The line may mean nothing. Or it may mean that 1 billion years ago, someone decided to know the galaxy one system at a time. If so, then we are part of their knowledge now. We are written in their archives, our air, our seas, our signals stored in a ledger older than our species. And when the next visitor comes, carrying updates for that record, it will look down at a small blue world that knows it is being watched and is, finally, watching back. The story doesn't end with 3i Atlas. It continues in every detection alert, every new telescope, every child who looks up and feels that ancient pull toward the unknown. Because maybe the real message of these objects isn't that we're being studied. Maybe it's that the galaxy expects us to learn, to measure, to question, to reach. And one day, when we send our own probes beyond the sun's gravity, threading the same corridors, crossing other skies, someone somewhere will notice the symmetry: 3 visitors from a small blue world, each carrying our chemistry, our questions, our name. Then they will wonder, as we do now, who is watching whom. Decades pass. 3i Atlas is a whisper, a case study, a footnote in academic syllabi. The world has moved on, but the telescopes have not. They keep their vigil, because once you see a pattern, you can't unsee it. By the mid-2040s, the 4th interstellar visitor is confirmed. Designation: 4i Perseus. Inbound from the direction of Lyra. Velocity: 74 kilometers per second. Inclination: 4 degrees. Trajectory: descending through the same narrow ecliptic plane as Atlas. Its first waypoint prediction: Mercury, then Earth's orbit, then Saturn. For the first time, we are in the corridor. The news ignites the planet. Every observatory on Earth goes on alert. The Interstellar Object Rapid Response Network activates. 2 interceptors, Aquila and Kibbo, are cleared for launch. Each carries a miniature spectrometer, radiation shields, and autonomous AIS built to survive years without contact. No waiting this time. No missed opportunity. 6 months later, Aquila lifts from Cape Canaveral. Kibbo follows from Tanegashima. For the first time in history, humanity pursues a messenger from another star. The journey will take 9 months. Every nation contributes data. Every school streams the countdowns. We have turned curiosity into collective intent. As the interceptors close in, Perseus brightens. Early readings show a composition no one expected: nitrogen ice, ammonia crystals, and traces of hydrocarbons that don't match known solar system isotopic ratios. But something stranger emerges: faint modulation in reflected sunlight, a periodic flicker repeating every 8.6 hours. Too regular for random rotation. Too weak for an active signal. It feels like rhythm. A code written in reflection. The intercept happens on May 2, 2046. Aquila passes within 3,000 kilometers. Cameras record a nucleus almost black, irregular, yet strangely geometric. Flat planes where none should exist. Angles too crisp for ice fractures. One corner glints like metal. Then the signal cuts, dead, no transmission, no data dump. Kibbo reports a flash of radiation, a brief EMP pulse that fries half its instruments. When telemetry returns, Perseus has changed course by 0.0003 Australian dollars, tiny, deliberate. And then it accelerates. Acceleration beyond the model. Comets don't do that. Nothing passive does. Every propulsion explanation fails. Outgassing vectors don't fit. Thermal analysis fails. Energy output too stable. Something inside it moves. The scientific community fractures again. Some call it sensor error. Others call it proof. Governments classify most of the Aquila data. What leaks is incomplete: blurred frames, magnetic spikes, plasma disturbances, a silhouette half seen through the coma like a fractured spire wrapped in gas. No one agrees on scale. Estimates range from 30 meters to a kilometer. But everyone agrees on one thing: it wasn't empty. After that, the probes go silent. Aquila drifts. Kibbo limps homeward. And Perseus leaves faster than it came. In the years that follow, everything changes. Funding for deep space surveillance quadruples. AI-driven telescopes map every faint intruder out to $200. We discover dozens more too faint, too small, but all following the same nearly coplanar, retrograde lane. A highway we never noticed. A galactic transit line cutting through our system. The pattern is now undeniable. The inclination range is narrow. The distribution of approach vectors clusters around one geometry, one invisible highway slicing across the planetary plane. Whatever these objects are, they follow rules. Rules imply design. By 2052, the International Astronomy Union quietly changes its classification code. Interstellar object becomes interstellar messenger candidate. A linguistic shift with seismic weight. It is no longer fringe to ask what they are. It is policy. And then comes the signal. On October 12, 2053, Deep Space Antenna VL-16 in South Africa catches a narrowband transmission from beyond Neptune's orbit. Frequency, 8.6 GHz. Duration, 86 seconds. Repeating every 8.6 hours, the same rhythm as Perseus's flicker. Not audio. Not language. A structured binary waveform that matches no known natural emission. The transmission is faint, decaying with distance, but triangulation places it along the outbound path of 3I Atlas. The comet that left nearly 3 decades earlier. The signal repeats for 4 days, then stops. Analysis reveals mathematical structure, prime intervals, harmonic ratios, recursive loops. Not random. Information. And then, silence again. We send nothing back. The consensus: listen first. No broadcast. No invitation. Just observation. In the following months, observatories across the world confirm sideband echoes. Weak reflections, mirrored and delayed, as if something at the edge of the solar system were listening to our own transmissions and bouncing them back, not verbatim, but transformed. Delayed by minutes. Altered subtly. Enough to say, heard. By 2055, the idea of galactic census is no longer theory. It is curriculum. Children learn that our system sits on a route mapped by objects that come and go in patient silence. We are one coordinate in a survey that began before mammals evolved. And yet, life on Earth goes on. Cities glow. Nations argue. People marry, work, dream. But above it all, an awareness hums. Someone, something, knows we are here. The data shows it. The geometry confirms it. We are catalogued. And with that realization comes a change in attitude. Space exploration becomes less about conquest and more about participation. We stop asking whether to announce ourselves. We already have. Every radar ping, every transmission, every interceptor launch, data entries in someone's log. Humanity begins to mirror what it suspects. We send our own survey craft outward, Voyager 3, Atlas Responder, Gaia Reach, machines designed not to return, only to listen, to observe, to join the quiet traffic between stars. Because understanding requires presence. Because curiosity demands parity. Decades blur. The catalogue grows. By 2080, 23 interstellar messengers have been confirmed. Different chemistries, different shapes, same lane. Some show jets. Some are inert. All move with intention disguised as coincidence. We still don't know who sent them. Maybe no one. Maybe the senders are long gone, their machines running on ancient orders. Maybe they are the galaxy's immune system, measuring, recording, updating life's ledger. Or maybe they are us, future echoes from civilizations that learned how to fold time. Whatever they are, the pattern remains. They come, They measure, they move on. And somewhere, a database updates. Planet 3, technological. Biosphere stable. Status, ongoing. In the end, 3i Atlas becomes more than a comet, more than a mystery. It becomes a mirror. A reminder that the universe is watching, not with malice or favor, but with patience. That observation itself is an act of recognition. And on a clear night, when the sky is still, telescopes idle, and the deep receivers whisper through static, you can almost believe you hear it. The soft, structured pulse of something far beyond our reach. Counting, measuring, remembering, and waiting for us to understand what the numbers mean.